This is an introduction to limits for honors pre-calculus. A graphical approach is the first thing we're going to do. The equation of the function graphed to the right is 2x squared plus 5x minus 3 over x squared minus 9. And we're giving you the coordinates of the hole in the graph. So that's negative 3, 7/6. As x approaches negative infinity, the graph of f of x is approaching, well, it appears it's approaching 2. I mean, it looks like there's a horizontal asymptote here. And if we did some analysis of this function from just understanding rational expressions and rational functions, we would see that that graph approaches 2. And likewise, as we approach positive infinity, it looks like there's still a horizontal asymptote at 2. Well, what we would do now, if we are extending this to understanding what limits are, we would just start using a new notation. So our notation would be the limit as x approaches negative infinity of f of x equals 2. That's going to be our new notation. And here's what the parts of the notation are. This limit is kind of like, it's kind of like something where if you put it here, you have to have something after it before an equal sign. So similarly, when you have sine, you have to have an angle on the inside. When you have limit, you have to have some sort of function after the limit. So if you don't have a function, you could put the whole thing here. You could write that out, but I'm just going to write f of x because it's a little shorter, but you have to have a function here. Then that equals some sort of value. So this is like one entire unit of things. You have to have the entire part in order for it to make sense. And so it's limit, and then it's as x approaches something. So basically we're going to copy this, and then f of x, whatever we're looking at, goes here, and then whatever the y values approach goes here. So limit as x approaches negative infinity of f of x is 2. Likewise, the limit as x approaches positive infinity of f of x is 2. Now let's look at what happens as the graph of x, or the graph of f of x, approaches negative 3 for x. So that looks like this, and it's from the left, right? So if we're approaching from the left, that means we're coming from the left side. It looks like it's approaching 7/6. So if that's the case, we're going to say the limit as x approaches 3 from the left. So we would have x approaches 3, or negative 3, I'm sorry, negative 3 from the left. So we put a little negative sign up in where an exponent would be. That represents negative 3 from the left of f of x equals 7/6. Likewise, the same thing appears to be true as we approach from the right. So as we approach from the right, we would say the limit as x approaches negative 3 from the right of f of x equals 7/6. As x approaches negative 3, the graph of f of x approaches 7/6 because it approaches the same thing from the left and the right. So we would say that the limit as x approaches negative 3, limit as x approaches negative 3 of the function is 7/6. Now what about positive 3? Well, as the graph is coming from the left side, it looks like the graph of f is approaching negative infinity. So we would say the limit as x approaches 3 of f of x is negative infinity. And from the right, that means from this side, the graph is going to approach positive infinity. And that makes sense because we have a vertical asymptote at 3. So the limit as x approaches 3 of f of x equals positive infinity. So if the limit from the left equals the limit from the right, and I'll just call that capital L, then that means that the limit in general exists. So the limit as x approaches a in this case exists. But if the limit from the left does not equal the limit from the right, then the limit of the whole function at that point a does not exist. We also have a couple of pictures to explain how it's possible for the limit and the function value to be different at certain points. So the one on the left, notice that the limit as we approach 2 is going to be y equals 4, but the value of the function doesn't exist. The middle one, the limit doesn't exist because from the left and the right, they don't equal the same thing, but the value of the function is 1. And then the one on the right, the value of the function is -3, but the limit actually does exist, and it's a different number. The limit is y equals 6. So I've inputted all of these things into the calculator and found decimal approximations for all of these things as I plug in -1,000 for x and -500 for x and all these other things. So I get these decimal approximations. And we're going to analyze these exact same things that we did graphically, but now we're going to look at them numerically. So what's happening as the limit of f of x, once again, you can write limit with the function with all the x's in it, or you can just say limit as x approaches -infinity of f of x. These two things mean the same thing in this problem. So what is happening as we approach -infinity? Well, as we go this way on our table, it sure looks like the graph is approaching 2. And likewise, as we go this way on the table and the x values approach positive infinity, it looks like these numbers are getting closer and closer and closer to 2, but never quite touching them. So that is equal to 2 as well. How is the numerical analysis related to the graph? Both appear to approach 2 without touching 2. I should say f of x or y equals 2 without touching y equals 2. And that's kind of what it means for a limit. So a limit is what we approach as we get to a certain value. Could the limit be equal to something that we actually have? Yes. But sometimes the limit is equal to something, but the function isn't. And in this case, the limit is equal to 2, but the function never equals 2 as we approach positive or negative infinity. It always stays close to the asymptote and never touches it. So now let's take a look at what happens as we're getting close to 3. So as we're getting close to 3 coming from the left, it looks like we're getting close to -infinity. And that, if we look at the graph and we approach 3, we remember that this graph went something like this. And sorry, there's an asymptote at 2. Terrible graphing, sorry. As we approach 3 from the right, so coming from the right, our graph approaches positive infinity. So it looks something like this. So what are the values of these things? -infinity and positive infinity. And the numerical analysis is related to the graph because the graph shows you, so it's like a visual versus a numeric approach, but you end up getting the same thing. Both of these things have, they approach the same value, OACH. We're just looking at it in a different way. Okay, so we have a table of values for a rational function. So a rational function is something that has a numerator and a denominator with polynomials in both. Use the table to find the limits that follow. There should probably be an S there. Limit as x approaches -infinity of f of x. So if we take a look at what happens as we approach -infinity, it looks like it's getting really close to 2. The limit as x approaches -1 from the left. So if we're going to -1 from the left, we're starting and we're kind of getting close to here. So it looks like that one's approaching positive infinity because these numbers seem to be getting really, really big. The limit as x approaches -1 from the right, well, that would be going this way. That appears to be negative infinity because these numbers are getting really, really negatively large. So then our question is, what is the limit as x approaches -1? Well, since if we approach -1 from the left, we get infinity, and we approach -1 from the right, we get negative infinity. This does not exist. It does not exist because these two things are not the same. If they are the same, then we can say that the limit at that value exists. But since the limit does not reach or approach the same value from the left and the right, we would say that the limit does not exist. So if we take a look at what happens as we're approaching 2, it looks like, and again, we can't be sure because all we have are certain values, but it looks like we are approaching 1/3 in both directions. So from the left and from the right, it looks like we are approaching 1/3. Therefore, we would say that the limit as x approaches 2 is 1/3. One thing to note is that if I said, what is f of 2? That's undefined. So it's okay for a limit to be equal to a number, even though the function doesn't have a value at that point. What is the limit as x approaches infinity? Well, our table appears to be going off the page, but it looks like that's also 2. So now we're going to use this graph to find the value of the following limits. Limit as x approaches -infinity. The limit as x approaches -infinity looks like, if I could plot the trajectory, it looks like it's going to 0. Looks like this might be a horizontal asymptote going to the left. Limit as x approaches -2 from the left. So if we're approaching -2 from the left, that means we have to come from the left side of the graph. That is positive infinity. Limit as x approaches -2 from the right. We're approaching from the right and we're going to -2. That's negative infinity. Limit as x approaches 1 from the left. So if we approach 1 from the left, that's approaching y equals 1. Limit as x approaches 1 from the right, that's approaching y equals 3. Since these two things are not the same, I have to say that the limit as x approaches 1 does not exist. And then it appears that as I approach positive infinity, I have y equals positive infinity. It does not look like there's any sort of asymptote going on. It looks like it just kind of keeps going up forever. So that's kind of what's going on here. One other thing I kind of want to talk about is, what is f of 5? F of 5 does not exist, right? There's an open circle there. But what is the limit as x approaches 5? Well, the limit as x approaches 5 of f of x, it looks like that's 5. It looks like that's 5 because from the left and the right, it looks like we're getting really, really close to 5. So I wanted to talk about that as well. So let's do this one really quick, then we'll be done. Use the graph at the right to find the value of the following limits. Limit as x approaches -3 from the left. As x approaches -3 from the left, we're going to positive infinity. -3 from the right, we're going to y equals negative infinity, which means since these are not the same, the limit does not exist at -3. Limit as x approaches 2 from the left. So 2 from the left, looks like that's 1. The limit as x approaches 2 from the right, looks like that's 6. Therefore, the limit does not exist at 2 because these two things are not the same. Limit as x approaches -5 from the left. So from the left means like this. That's 4. Limit as x approaches -5 from the right. That's 4. Limit as x approaches -5. Since these two things are the same, I can say that's 4. Now what's f of negative 5? That does not exist because there's an open, oh, well, actually I lied. It does exist. There's a filled in circle here at 1. So it is possible for the limit as x approaches negative 5 of f of x to be one number, and the value of the function to be another number.